Hello students, today we are looking at estimating and bounds. So by the end of this video you should feel more confident in the following topics: estimating the value of calculations, estimating the value of square roots, and bounds when numbers are rounded and also when numbers are truncated. Firstly, we're going to be looking at estimating. So when estimating, we round all of the numbers to easier numbers, so it's easier to calculate mentally. We usually round numbers to one or two significant figures. We don't just round at the start either, we can round midway through if it seems reasonable. So let's have a look at our first example where we've got 102.6 times 2.98. Mentally this is quite a difficult calculation to do. So what we can do is round both of the numbers to numbers where they are only to one significant figure, and this would simplify a calculation. So if we've got 102.6 to one significant figure, that is just 100. Now if you're unsure on significant figures, we've got a video on significant figures and rounding to decimal places earlier in the numbers topic, so if you'd like to look at that, I'll put it in the link below. And then 2.98 to one significant figure is just 3, so now I've left 100 times 3, which is actually equal to 300. Now the actual answer for this calculation when not rounded is equal to 305.748, but mentally this is very difficult, so 300 is actually quite close to this answer. So if I have a look at the second example, this is where we're going to have to remember our tip. We can round midway through calculation if necessary. So we'll start off with the top part, so we'll round these all to one significant figure. So we've got 102.4, which would just be 100. We've got 3.12, which to one significant figure is 3. And underneath we've got 2.9, which to one significant figure is 3. And we've got 8.2, which to one significant figure is 8. Then we can simplify the top and the bottom, because 100 times 3 is 300, and 3 times 8 is 24. And then now we can round midway through calculation if necessary. 300 divided by 24 is quite a difficult calculation to do. So what we can round this to is to the nearest 10, which would leave us with 300 divided by 20, which is quite easy to complete mentally, and we know the answer is 15. Alright, so now we're looking at estimating the value of square roots. To do this well, you should know the first 12 square numbers from memory. So the first step when estimating the value of square roots is to find which two square numbers the number is in between. So here we've got 68, so we can write square root of 68, and which two square numbers here are the in between. So I can see it's between 64, and it's between 81. And we already know the square root of 64 and the square root of 81. The square root of 64 is 8, and the square root of 81 is 9, which means that the square root of 68 must be between 8 and 9. It's closer to 8 though, so we know that the number must be closer to 8 than it is to 9. So we could take an estimation of 8.2, and that would be our estimation because it's closer to 8 than it is to 9. Alright, so here are some questions based on what we have just learned. Please pause the video now if you'd like to attempt these questions. Okay, so now I'm going to be going through the answers to these questions, but first we're going to get estimations up. So we're going to round these to one significant figure, so we can get this to 30 times, and then 18.2 to one significant figure is 20. So 30 times 20, which we know is equal to 600. And the actual answer for this question is 622.44. So it's actually quite a close result we got there. So let's have a look at question 1b. So 614 to one significant figure is 600. 49 to one significant figure is 50. And 5 is already one significant figure, so we can leave 5 as 5. Now remember, BODMAS, we actually have to complete the division first. So 50 divided by 5 is 10. And so we're left with 600 times 10. And our result is 6,000. Now the actual answer for this question is 6,017.2. So it's actually fairly close again. So now looking at for the square root of 24. So the first thing we have to remember is which square numbers are in between. Well, two square numbers which is in between is 16, which is 4 squared, and 25, which is 5 squared, which must mean that 24 is in between 4 and 5. Well, much closer to 25 than it is to 16, and it's actually only one digit away, so 24 from 25. So we can say it's closer to 5 than it is to 4, and I would go with the estimation of 4.9. The actual value for this was 4.899, so this estimation was actually very close. So for question 2b, we've got the square root of 79. So now we need to recognise which two square numbers it's in between. Well, the square number which is above it is 81, which is 9 squared. And then the number to the left of it would be 64, which is 8 squared. So 79 would go in the middle. Now, is 79 closer to 64 or is it closer to 81? Well, it's actually only two numbers away from 81, so I'd say it's closer to 9, which means that if I was to give an estimation, I would give it to 8.8. The actual value was 8.9, so once again, very close. When numbers are rounded, bounds are created. The bounds are half of the smallest unit, bigger or smaller. This can be explained if we have a look at an example. So if we have a look at 61, we can only assume that 61 has been rounded to the nearest whole number because there's nothing past the decimal point. But there might have previously been a number there and it's just been rounded to 61. So if we have a look, what's the lowest number 61 could have been before it was rounded to the nearest whole number? Well, it could have been 60.5 because that would round to 61. So that would be our lower bound. And the higher bound would in fact be 61.49 recurring. So this range could actually be defined as, we could put x in the middle and it'd be 60.5 because x is greater than or equal to 60.5, and then it is less than 61.5. So anything less than 61.5 but greater than or equal to 60.5 could be defined as what this number was before it was rounded. Another way of writing this range could be 61 plus or minus 0.5. So let's have a look at question 1b. Find the upper and lower bounds of 1.5 if it was rounded to one decimal place. So if you've got 1.5 here and it was rounded, so we managed to get this 5 from when it was rounded, we need to think what the lowest possible number it could have been and the highest possible number it could have been. So the lowest possible number it could have been is 1.45 because that would round up to 1.5 if it was being rounded to one decimal place. The highest number it could be is 1.54. So we can actually write this range as, again, x, so x would be greater than or equal to 1.45, but it would be less than 1.55. We could also write this range as 1.5 plus or minus 0.05. Okay, so truncation is slightly different to rounding. So when we round, we consider the number after the last digit to be a decider, but when truncating, no rounding is done at all. So if we have a look at this example here, if 80.1 and then lots of 9s was rounded to one decimal place, we actually get 80.1, not 80.2, and that's because we found our one decimal place, which is here, and then we just ignore all the numbers past the decimal place when we're truncating, so we're just left with 80.1. So for example, if we have a look at question 1a, it's asking for 60.248 truncated to two decimal places. So we find our two decimal places, which is 60.24, or two digits after the decimal place, and then we just ignore the 8. So that's 60.24 to two decimal places truncated. You just ignore any numbers past what you don't need. We don't round and we don't use it as a decider. So if I have a look at question 1b, we can see that it's asking for what is the lower and upper bound of 60.4 when it was truncated to 1 decimal place. We've got to think of what the numbers could have been. So the lowest possible number, so it's 60.4, so what's the lowest number that could come after? Well, it would be 0. So 60.4 would be the lowest possible number that it could have been before it was rounded. The highest possible number it could have been is 60.49 with lots of 9s coming after it. It could not be 60.5 because then that would be truncated immediately to 60.5. So we can write this range as x is greater than or equal to 60.40, and then you could say that x is less than 60.5. Thank you very much for watching. For more videos, please visit www.gcsemathsresources.co.uk.